All right, we're going to start. So welcome to the Swedish NLP Seminar Series. My name is Magnus Ahlgren. I will be the moderator here today. This is a bi-weekly seminar series that we run co-organized by AI Sweden and RISE. And we do this every second week, obviously on Wednesdays at 3 o'clock. Nowadays, we also start with Fika here at the AI Sweden office. So if you sign up for co-working, you can come here and take the Fika before the seminar. New for this year also that we have the event space here in Stockholm, but we also have an event space in Gothenburg, which is here online. Can you wave in Gothenburg? Yeah, so selected dates will be available. If you're in Gothenburg and you want to attend the seminar, you can sign up and join from there also. But we will continue the hybrid form. So sometimes we have speakers that join us online. Sometimes the speakers will be here in Stockholm. And during this spring, we will mainly focus on having speakers here at the office. Let's see. I want to also just mention that we have now released our GPT-3 model as a pre-release. So if you are in the Nordic region, you can sign up for access to the GPT-3 model, and there will be a link in the chat soon where you can sign up for that. Please do. We also have a Discord channel where you can sign up, and we discuss all things related to AI there. GPT-3, of course, but also vision, speech, and things like that. And there will also be a link in the chat soon. At this seminar, we try to select topics and speakers that are relevant and interesting for the Swedish NLP community. And today, I think we really can tick both boxes, interesting and relevant. So I'm very happy that we have Sebastian Ruder as our speaker today. So Sebastian is a research scientist at Google. I'm sure many of you follow his blogs and newsletters. Sebastian has worked a lot on representation learning, transfer learning, multilinguality. And the topic of today's presentation is challenges and opportunities for underrepresented languages. And I think this is particularly interesting, perhaps for the Swedish community. I think sometimes we feel like an underrepresented language. Sometimes if you compare Swedish to other languages, we might be not so underrepresented. So I think one interesting question for Sebastian, and maybe we will learn during the presentation, is to what extent is Swedish an underrepresented language? And we can maybe discuss that. So with that, Sebastian, the floor is yours.
Cool. Yeah, thanks so much for the kind introduction, and it's great to see so many people in the audience. Yeah, sorry that I can't be there in person. Let me share my screen now to begin. And I hope you can all hear me now as well. And yeah, so just let me know, shout if there's any issues throughout the talk. And we can also stop like halfway maybe for questions, or yeah, otherwise we can take questions at the end. All right, yeah, so as already mentioned, so the talk will be today about challenges and opportunities in NLP for underrepresented languages. But yeah, I hope some of these things I'm going to talk about are also going to be relevant in the Danish NLP ecosystem. Sorry, in the Swedish NLP ecosystem, but generally for like Scandinavian languages. And here is just a kind of rough structure of the talk. So in the beginning, I'm just going to talk about prior work in this area and generally the status quo, just to get us all on the same page. So people who are working in NLP and people who are working maybe on different research areas. Then I'm going to talk about recent progress in this area, as well as some of the challenges that I think impede future work in this broader area. And finally, I'm going to talk about kind of what I envision as some of the most important directions to focus on in terms of resolving the challenges that I'm going to mention. And generally, when talking about NLP, particularly for languages around the world, I think a particularly important topic to discuss is the issue of language diversity around the world, and particularly with regard to language diversity in NLP research. So many of you might already be aware that there are a huge number of languages actually spoken around the world, typically estimated to be around 7,000 languages. And if we kind of zoom in a bit further at those languages, we can see that about 400 of them are spoken by more than 1 million speakers. And even if we look kind of to the languages spoken by 100,000 speakers, we are still dealing with more than 1,000 languages. And I think that personally, when I first learned those kind of speaker numbers, was a bit surprising to me, because I think generally we think about doing NLP for like major world languages or like a handful of languages that are typically represented in NLP research. And I think it's quite underappreciated that actually so many more languages are spoken by tens of thousands or millions of speakers around the world that are very much underrepresented by our models or by our current data sets. And throughout the talk, kind of a particular region and a particular set of language families that I'm going to focus on is the set of languages spoken on the African continent. And one reason for that is because Africa is particularly linguistically rich and diverse. So Africa itself has about 2,000 of those 7,000 languages spoken on the continent. Of those, there are around 100 languages that are generally kind of used as lingua francas, so widely used for communication even across different regions or different borders in different countries. And then again, there are more than 10 languages which are each spoken by tens of millions of speakers. Now, kind of let's look from the general language diversity of these languages around the world to language diversity with regard to NLP research. And here we can firstly just look at how often these languages are referenced or mentioned in papers in kind of the NLP literature, so in the ACL anthology. And if we just look at kind of the mentions of different languages, we can plot them based on the number of papers per million speakers. We can see here the number of papers per million speakers and the population in terms of million speakers. We can see that there are a couple of languages like Irish or Basque, for instance, which are quite disproportionately represented with respect to the number of speakers in the research community. Then we have what are typically considered kind of major world languages like English, Chinese, or even German, which have quite significant speaker populations, and also get their fair share of research attention. And kind of on the bottom rung of this hierarchy, we then have languages like a lot of them in Africa, which have still millions of speakers, but are comparatively significantly underrepresented in NLP research. And kind of in comparison and putting that into context in terms of like Swedish, for instance, like most European languages will be kind of found in the middle parts of this hierarchy. Now looking from the languages themselves to the people who are actually doing the research, and particularly speakers of those languages working in NLP research, we can plot basically the representation, so the affiliation of the researchers based on the country or the nationality of that affiliation. And if we do that for African institutions, for instance, for both NLP and ML venues, we can see that kind of over the years, there hasn't been not really much of a change, a slight uptick in the end. But in general, the number of African researchers actually who are represented in the NLP or ML communities are really in the single digits typically. And this kind of, if you just look at this, this might be maybe not that meaningful, but in practice, you need to see this in comparison to the thousands of people who are actually doing research and publishing in those venues, and compared to this huge number of like papers that are published every year in ML and NLP venues, having just tens of digits of representation by African researchers really pales a lot in comparison, and really kind of demonstrates the kind of disproportionate representation of not only the researchers, but also the languages in our community. Now, just kind of moving from the particular state of these languages to the broader state of NLP research. And I think most of that will already be familiar to you if you're working in NLP these days. In kind of my view, there are two main ingredients that make up most of the state-of-the-art approaches in current NLP. Which are firstly kind of a general purpose architecture that can be scaled and adapted to large amounts of data, which is kind of the transformer as the go-to architecture these days. And combine that with transfer learning. So transfer learning, in this case, meaning that we can take a model and can pre-train that in a self-supervised fashion on large amounts of unlabeled data, typically from the web or Wikipedia. In the past, this has been done with different methods like Word2Vec or GLOV or Elmo, going all the way to deeper representations, and more recent methods like BERT, GPT, or T5. And these models, because they've been able to learn very general purpose representations in pre-training, can then be adapted either during fine-tuning, typically, or more recently using in-context learning to a wide variety of different tasks. And typically, this recipe in practice typically yields state-of-the-art performance across many different application areas. Just to kind of briefly summarize one of the, I guess by now, somewhat classic approaches in this area. BERT consists of a stack of multiple transformer layers, which are basically built on token representations that consist of multiple components. This model is typically pre-trained by masking a random fraction of words in the input and then predicting their identity at the output. And it's typically applied, or the original model was applied to English and pre-trained in this fashion on large amounts of data. And in practice, it would then typically be fine-tuned on data of a particular task. For instance, here, natural language inference, where we have to identify the relationship between a premise and a hypothesis, whether they entail each other, contradict each other, or are neutral towards each other. The model is then simply fine-tuned on this type of data. Now, in the multilingual setting, and when talking about kind of multilingual or NLP for kind of broader set of languages, approaches can be seen kind of as analogs or multilingual counterparts to models that have already been very successful in the monolingual setting. And one of the most kind of common and standard baselines in this area is known as multilingual BERT, which is simply a BERT model that is now not only trained on data in English, but on data in multiple languages at the same time. And so in this case, instead of just in its vocabulary having words and subwords that are only in English, it now combines words and subwords in different languages at the same time. And then doing pre-training, the model essentially is pre-trained on batches of different languages, like here in English, as well as in Spanish, and up to 100 different languages at the same time by just sampling data in different languages, doing this sort of masked language modeling. And in practice, this model again has been shown to learn very general purpose representations. In this case, now not only covering one language, but representations that are somewhat cross-lingual, so that put different languages into the same representation space. And because of this, because the model has somewhat learned to kind of map different languages on top of each other, the model can then be fine-tuned on a given task. Again, here, for instance, natural language inference on data in just one language like English, and then can be applied to data in the same language in a zero-shot setting without ever having seen actually labeled data in the particular task in that language. And this kind of recipe of zero-shot transfer has been surprisingly successful or surprisingly kind of performant, at least in many different scenarios. Although, of course, in practice, it usually helps to have labeled data in the target setting or for the target language to additionally fine-tune the model on. Now, state-of-the-art approaches currently in this area of multilingual NLP very much follow this general underlying recipe. So most of these models are basically the variants of this underlying transformer architecture that mostly differ in the particular size and individual hyperparameter choices and the makeup of their training data. Most of these models also have quite somewhat larger vocabularies compared to their monolingual counterparts, because they now need to represent tokens from many different languages at the same time in their embedding space. And most models, even though they are multilingual, are still somewhat smaller compared to the largest monolingual models in practice. Now, again, from these kind of large multilingual models, let's zoom in again and look at how some underrepresented languages, like languages of Africa, are represented and are featured in these large models. And we can see here that models like multilingual BERT, for instance, and some more recent variants as well, have a number of or are trained on a number of African languages. However, compared to the huge number of African languages, it's still very much a small fraction in comparison. So they still include only very few African languages in the pre-trained data. And one reason for that is just a general lack of data for these languages in common pre-training data sources. So for instance, if we look at generally the distribution of different languages in common pre-training data sources like Common Crawl, so data from the web, or from Wikipedia, we can see that if you kind of plot the distribution of these languages, you can see on the right a lot of major world languages and a lot of Indo-European languages spoken in Europe or in kind of Western societies, with a very large kind of internet and online footprint. And very much to the right, or even not featured on this graph here, languages spoken in Africa or other developing regions of the world, where people do not use the internet so much, or the internet is not very common used in terms of creating online content. And even for languages where there is data that is online available, prior studies have shown that many of the existing online data sources, whether they are automatically collected using language ID or automatically mined using sentence alignment methods, actually have severe quality issues. So in a recent annotation study, for instance, the authors observed that a large fraction of languages in an automatically aligned corpus have severe quality issues and contain often less than 40% correct sentences. So less than 40% of the sentences that are supposed to be in a given language are actually in that language. And they're more often than not in another language, or maybe contain certain patterns of the web, or just noise, for instance, or HTML errors. For looking now, if you want to look at how these models actually perform on a broad set of languages, we need evaluation benchmarks or data sets where we can evaluate these models on. And a common kind of data set or benchmark for this has been this extreme benchmark on which I collaborated, which can be seen as essentially a multilingual analog to the GLUE benchmark, which has been credited and has kind of driven a lot of progress in monolingual transfer learning. And similar to GLUE, Extreme is a multitask benchmark that covers different tasks, now not only in English, but in up to 40 different languages, covering roughly different capabilities in terms of natural language understanding, from kind of more simple sentence classification tasks to structure prediction tasks, all the way to more complex question answering type of tasks. And the kind of aggregate score, the average performance across these tasks and languages, we can take as roughly as providing a glimpse of the model's underlying ability of generalizing to such a somewhat diverse set of languages. The scenario that is typically used in this benchmark and other settings for evaluation is this zero-shot cross-lingual transfer setting that I already mentioned before, where we take a model that was pre-trained on data in different languages and then fine-tune it on data of a given task, typically in a high-resource language like English. And then at test time, we can basically just apply this fine-tuned English model to data in all of the other languages at the same time and evaluate its performance on those languages. And in practice, this is kind of, at least in an evaluation setting, cheaper than fine-tuning it on each language individually. So it's easier to scale and set up. And it's also kind of usually driven just by the availability of data, because most of these data sets that are commonly used for model evaluation typically only have data in English, or training data in English, or training data in kind of a small set of other languages. So now if we kind of look at the progression of multilingual models that have been proposed over the last 2 years or so, comparing them with the initial like multilingual bird model that I mentioned, all the way to kind of more elaborate and more recent models, we can see that there's been kind of a general progression and general improvements in terms of the average performance of this benchmark, and that the performance has been kind of getting ever closer to like estimate of human level performance on this set of tasks. So generally, just by looking at this performance figure, we might get the impression that we are getting closer to actually reaching near human level performance, even in a multilingual setting with current methods. However, what these data sets and these kind of aggregate performance measure really belies is the sparse distribution of languages across the different tasks. So if you're looking, so on this table here, you can basically see at the as a column the different tasks, and as a row the different languages, and each cell in green is means that a certain language is represented in a given data set. And we can see here, based on kind of a pattern of tasks, that there's only very few data sets, mostly universal dependencies, and a weakly supervised named entity recognition data set based on Wikipedia that actually contain data in many languages. And most of the other tasks, the performance is only able to be calculated for a small subset of those 40 languages we actually hope to evaluate on. And particularly if we just zoom in on data for African languages, we can find that this problem is even more stark. In particular, African languages are only presented in a very small set of resources here, and we're not really able to actually get an accurate impression of the performance on a larger variety of different tasks in NLP. Now, taking a step back, we can also see the emergence of these recent multilingual models in comparison to the broader trend of large language models in NLP. And in doing this comparison, what we can observe is that there are generally kind of two different threads in terms of research if we plot models based on the fraction of non-English data that they're pre-trained on. So if we just look at how much multilingual data these models contain during pre-training, we can see kind of these multilingual models that I already mentioned at the top, which are trained on lots of data in different languages, and where there's been kind of a general progression of recent models. And at the bottom, what is arguably kind of the mainstream of NLP research, which has been much more English-centric in comparison, and which generally has produced kind of the largest models and the largest model size in practice, ranging up to 540 billion parameters with the recent PAL model. And the only exception perhaps here is the recent Blue model produced by the Big Science Workshop, which is also much larger than previous multilingual models, and kind of the first model that was really produced by a large community effort in practice. But the overall trend, at least, has been so far just mainly by kind of industry or other institutions producing these large language models, has been to focus mainly on kind of an English-centric context. So overall, kind of one hope is also that these two research streams will kind of merge together, hopefully eventually, and that the community will focus on developing models that can support a broader set of languages kind of jointly. So the main takeaways from this section is essentially that there's really a discrepancy at the moment between the huge language and the linguistic diversity around the world and the comparable kind of scarcity of these languages in the current NLP research. On the other hand, we have state-of-the-art models and evaluation resources that are to some extent highly multilingual, but still contain very few of these actually low resource and underrepresented languages. And the kind of main side effect of that is that these models consequently also perform poorly on those languages that are underrepresented in their pre-training data. So with this picture so far in mind, I want to highlight some more cause for optimism and some more recent progress in this area of NLP for underrepresented languages. And this kind of is not only related, this overview is not only related to research advances, but also to kind of new structures and new initiatives that emerge from the community. And one kind of thread I want to highlight here is just the development of more grassroots communities of researchers working on specific languages that have so far been underrepresented or neglected. A particular example is the Mazakana community that does NLP for African languages by African language researchers, which as of kind of middle of this year had more than 1,600 members from different African countries. And this was kind of conceived at a deep learning GABA, essentially this ML conference for African ML researchers. And initially, essentially started out by focusing on just a particular application, machine translation for African languages, but since then expanding to both a larger variety of areas, as well as more modalities, which have culminated up to now to kind of broad range of different community-produced applications in a diverse set of different ML and NLP areas. Beyond that, there's kind of a wide variety of other communities that have emerged in the space, from communities focusing on specific African languages, for instance, like Hausa or Ghanaian languages, to repositories or other organizations that try to make it easier to discover or to surface information or data sets associated with different languages. There's also, I think, just a stronger ecosystem supporting different efforts as a whole. For instance, Zindi is a network, kind of the Kaggle of Africa, so the network and organization hosting hackathons and other community events in Africa. While the African Masters in Machine Intelligence is essentially a Pan-African initiative that organizes a rotating master's program in different African countries. And these kind of initiatives really, I think, help to educate and also to foster the next generation of researchers and practitioners in the NLP and ML space. There have also been some new funding structures in this area. For instance, the Lacuna Fund, which has been supported by different organizations, has had 2 calls so far, specifically on NLP datasets for African languages, which have already funded quite a diverse collection of different datasets. And just to give a couple of examples here, so there's different data sets focusing on different subsets of African languages, as well as different modalities, both for text and speech, and different types of NLP applications like summarization here, or news classification, as well as also going beyond African languages, for instance, for languages of the Americas as well. Just to give like a couple more highlights of these data sets, and why I think they can be useful not only for NLP researchers for these languages, but also kind of in a broader NLP context. Because a lot of these data sets can present interesting linguistic and language phenomena. For instance, a sentiment data set here for Nigerian languages using Twitter data, representing and featuring a lot of examples of code switching, not only as is very typical code switching between English and target language, but also code switching between different African languages that are spoken in the Nigerian context, even sometimes with up to 3 languages in the same tweet. Or similarly here, a data set of different named entities that are annotated in news articles for a representative subset of African languages, where you can also see here that generally kind of a standard task named entity recognition, as it's currently studied, also might present some new challenges when looking at languages in the African setting, where we might have to deal with different alphabets or different scripts, like in Amharic, for instance, or just generally different ways in which temporal or expressions are expressed, like in Wolof, or just different ways to express different entities that differ across languages. There's also kind of additional kind of interest and work from industry. Particularly, there's been a couple of local startups that also have published and produced interesting work in the space. For instance, InstaDeep and iCompass working on language models for certain dialects of Arabic, like the Tunisian dialect, or generally startups focusing on kind of challenges in the local area, such as developing technology to help with to provide NLP for financial services in the local languages. And probably one of the biggest developments in larger tech companies has been kind of the emergence of machine translation models and machine translation data in a broader set of languages, and just more studies in terms of how machine translation in particular can be scaled towards a larger set of languages. And lastly, also with the kind of NLP and scientific community, there have been kind of promising initiatives in this line. From ACL had a theme track last year focused on language diversity. And also currently has the special initiative on globalization by localization that focuses on automatically translating the entire ACL anthology into 60 languages, but also providing automatic subbing and dubbing of scientific talks and conferences, which can enable broader access to scientific communication and NLP research for speakers in these languages. And yeah, finally, there are also kind of community events, which I think have really helped in terms of bringing together and allowing people to exchange ideas and really share and share ideas and collaborate in the space, from the Deep Learning Lab as well as to local kind of workshops and competitions like the America's NLP competition. So in terms of what I mentioned before, in terms of research advances in the current state of NLP research, there have also been kind of new research developments. I already mentioned before kind of the comparative underrepresentation of African languages in current NLP models. And kind of one trend, one thread of research that has sought to address this kind of imbalance in terms of language representation are specific models that are particularly adapted for African languages. And these new African models, rather than trying to capture representations in around 100 languages, focus only on 10 to 20 different African languages, but in practice are really much better and are much more efficient and compute efficient in terms of learning representations for this smaller subset of related languages. So the main takeaways from this part of the talk are essentially that I think there's a lot of cause for optimism in this area. There's really, I think, a blossoming ecosystem, particularly with regards to NLP for certain languages that have so far been underrepresented, and a lot more people and researchers that are excited to work in this space. This has mainly come from both grassroots initiatives, but there's also, I think, increasing awareness and interest from existing institutions and organizations to support or enable additional work in this space. Now, kind of looking ahead, I want to highlight what I think are 3 challenges for making progress in this area. The first one being limited compute, limited data, and dealing with different language typologies or different linguistic features. With regard to the first challenge, I think this is probably the most kind of pervasive and the most acute one to actually deal and learn strong models in this area, which is the fact that there's only limited amounts of data, both unlabeled and labeled, available for most of the world's languages. And I think one nice way to kind of illustrate this lack of data is to borrow the taxonomy from Yoshi et al. From 2020, which essentially characterized different languages based on the amount of unlabeled and labeled data that they have available. In their case, they used Wikipedia and kind of existing data sets that were tracked as part of the LRAG data map to quantify these data sizes. That similar kind of taxonomy can be scaled to data on the web or other data sources as well. And what they came up with is that languages in the world can be roughly clustered into 6 different groups based on the amount of data available to them. In the most high resource group that you can see here in the chart represented on the with the number 5 on the top right, we have kind of major world languages, English at the very top right corner, and a lot of European languages, which both have abundant unlabeled data as well as a lot of existing labeled data sets available. While most of the world's languages, unfortunately, fall into the 2 most lowest resource categories here, where they either have no text data available to them at all, or very few limited amounts of unlabeled data, and basically no or very little labeled data at the same time. Beyond that, beyond language, beyond simply the amount of data, these languages also face kind of additional constraints, particularly when it comes to actually developing technology that can be used and successfully deployed in the local scenarios, or actually developed by researchers or practitioners working in those regions. And a particular constraint here is simply the amount of compute or computational resources available, which may either be very expensive or simply unavailable or unobtainable in many circumstances or for many regions. And one kind of particular indicator, for instance, can be the cost of mobile data, which is also correlated with a particular resource group from the previous slide. The last challenge here that I just want to highlight is the kind of difference in terms of linguistic features and language characteristics of across the world's languages. And what we can see here is if we plot the world's languages, so if we take the linguistic features from a very widely used database of linguistic features called the Word Atlas of Language Structures, and project them into 2D representation using PCA. And then for each language, here in the density plot, we can then put a red star where which language is represented in an existing multi-modal data set, like the universal dependencies. And we can find that most languages that are currently represented in existing data are generally associated or fall in low density regions of the plot. So most languages that we have currently data for are quite unrepresentative of most, in terms of the linguistic characteristics of most of the world's languages. And the underrepresented languages that we would like to deal with, such as African languages, for instance, have many linguistic features that are not really present in European languages, for instance. And one of these is, for instance, like rich morphology. So many languages are much linguistically richer, morphologically richer than English or similar European languages. While another very common feature that is also underrepresented in a lot of languages we're typically working with is tone, which is presented in about 80% of African languages, where tone can either indicate kind of lexical or grammatical meaning. For instance, in Yoruba, where lexical tone can distinguish meaning between different words that would otherwise be spelled the same, and just differ in terms of how the different characteristics indicate the tone of the word. Or in Akan, for instance, where tone can distinguish different grammatical forms of the same word between the habitual and the stative form, for instance, here. And tone is really something that only recently has been starting to get explored for some of these languages, and it's generally still very much unexplored for speech in particular or NLP applications. And another kind of aspect of the linguistic topology here are language families. And one thing to note here is that the languages on the African continent, in terms of their adherence to a specific language family, are relatively more uniform. So there's only a couple of language families that all of these languages actually belong to. And so actually with learning representations or sharing representations across these languages is much more reasonable, despite this huge number of different languages that are spoken in Africa. And finally, I just want to mention also that there are challenges for responsible AI that I think we're only just kind of starting to grapple with and to approach, related, for instance, to data governance. So how can we make actually sure that the data technology we produce has the appropriate ownership or is appropriately used, ensuring safe and non-biased usage of this technology, particularly when it comes to collecting data from underrepresented speakers, collecting data in general using crowdsourcing, making sure that data preserves privacy, and actually ensuring that we develop technology not just by involving and kind of incorporating both the views and the speakers of those languages in the process as well, in a participatory fashion. So with that, I just in this kind of final part of the talk, I just want to highlight kind of what I think are like one useful direction in this line. So just due to time, I'm only going to focus on kind of the first part here, just as one way that we can deal with the amount or the limited amount of data that is currently available. But we can also talk later, for instance, about some of these other aspects or other directions in general. And here, so in this context, in terms of actually collecting or overcoming this limitation of existing data, I think it's very important to look at getting and collecting data that accurately reflects the real world. So in my mind, this data has to be kind of fulfill a number of criteria. So it should be both practical, so reflect kind of needs of local communities. Another useful criterion is for the data to be multi-modal, for instance. So not just restricting ourselves to a single modality, and to take into consideration multiple data sources or if they are available. In terms of practicality, one downside of currently many multi-legal data sets or currently the most prevalent strategy to create multiple legal data sets in practice that are based on translation is that this so-called translation needs can be considered kind of a not actually natural language, but a dialect of natural language, which differs in many ways from the actual linguistic characteristics of naturally produced text or language. However, beyond kind of these surface differences, I think even stronger limitation of translated data is that the underlying data and the translated data is biased towards the original viewpoint of the annotators that produce the original data, which are typically crowd-based workers based in the US. And this can be seen looking at kind of a wide variety of different data sets, for instance, for question answering, which have been shown that even though they're supposed to kind of probe question answering performance in general, most of the data really is overrepresents entities that are of interest to Western and US-based crowd workers. So entities in the US and UK are vastly overrepresented compared to entities and people from many other nationalities. And this also kind of extends to many other data sets, not only in NLP. For instance, ImageNet, probably arguably the most widely used data set in ML in general, is also biased towards an English viewpoint because it was created using the English WordNet, and so contains many concepts that, even though they seek to kind of test general image recognition performance, really do so mostly with regard to a Western-centric viewpoint. For instance, for recognizing different very fine-grained dog breeds, or even certain concepts that are mostly common in a US-centric context, like tailgating, so having kind of a barbecue on the trunk of your car. So going forward, I think it's really crucial to think about and try to produce that data that's not only relevant, but that also represents usage scenarios that are important or practically relevant in these different regions. And these can kind of range from different applications and different domains. And I think a particular benefit of that can be to have more practical impact with such research down the line and actually kind of lessen the gap from the research to actual practical applications. And one example, for instance, to highlight here is a company or a nonprofit in Uganda that tries to develop NLP technology to make it easier for lawyers there to interface with clients and to help them make it more efficient for them to provide legal advice for people in Uganda where just simply legal access or access to legal help is not available for many of those 50 million people in the country. Another thing to note when kind of talking about creating data or simply like looking at data in many of these contexts is that many of these components that we generally kind of take for granted that go into creating either a model or the data that a model is trained on, are simply not available for many languages. So here you can see roughly like the language model development cycle, with consisting of different stages, both in terms of creating the original data from someone actually creating the content that is then maybe annotated, curated using different tools, from then researchers or AI technologists working on training models and doing some human evaluation in the end. And in many cases across underrepresented contexts, both the connections to those different stakeholders might not be available. So it may be very difficult to find annotators or simply people who can create very high quality natural content or natural text in different languages, or in many cases, even some of the tools that we take and use on a daily basis, like keyboards using different scripts, might be unavailable or not really suited for the needs of those different speakers. So I think generally kind of one particular direction is really trying to use our technology and actually making this sort of data generation and annotation process more efficient, and really figuring out how we can use the limited amount of native speakers that we can get access to and their language expertise to maximum effect, maybe by incorporating them or working with them in different parts of the AI lifecycle, or using AI models to generate a large number of examples that can then be reviewed by humans and checked for quality, for instance. But I think this is an interesting space, but there's still a lot to be explored and to make this actually useful and practically impactful, because for many of these models, it's still very challenging actually to generate fluent content in particularly underrepresented languages. Multimodality, I think, is also very crucial, as I mentioned before, text on the web is rare for many languages. But that doesn't really mean a lot of these languages are low resource. It just means that the data is currently available in formats that are not currently able to be used or leveraged by our current models and our current training setups. And instead, the data that is available maybe in other formats like handwritten documents, in books that so far haven't been digitized, or in other types of modalities like radio podcasts or YouTube videos, for instance. And as Stephen Bird, another NLP researcher who has done a lot of work in the Aboriginal communities in Australia, has said, it's really crucial to kind of mobilize the archive to actually go out there and try to make use of this data that so far is really untapped and not usable for current NLP technology. And beyond that, many languages are also more commonly spoken than written. So for these languages, actually much more practically relevant to bridge and go beyond the text setting and develop methods that work also with speech directly. So in general, I think a lot of the models that we need to develop for these underrepresented languages need to be kind of inherently multilingual and multimodal, and be able to incorporate data from different sources. And I think, as I mentioned, this lack of data is kind of one of the key limitations here. And by focusing on this type of multimodal information, we can potentially overcome this reliance on just textual data, and which can drive increasing development of multimodal technology. And in particular, I think there's lots of interesting work that could be done in terms of investigating linguistic characteristics and how different things, different linguistic phenomena like tone can be modeled in text and speech by these types of models. But again, in order to better develop technology and models that are really relevant and useful for speakers, we also need to be aware of using multimodal data that really reflect the underlying needs of the speaker communities, like a recent multimodal data set for different image reasoning type of tasks that contains data in Swahili, for instance. So with that, there are, I think, some recent useful examples in this space that both do joint text and speech pre-training. So basically combining pre-training objectives of both text and speech models into kind of a similar architecture, as well as we also need new benchmarks that support the development and tracking progress in this kind of new emerging multilingual, multimodal space. And just to kind of give one example here, I think beyond using multimodal data, I think we also need to look for text data, for instance, for simply not just using the text that is available online, but all data sources that might help us learn better representations for these languages. And kind of if we plot the coverage of different language resources that are typically used to train these models, you can see here first that multilingual BERT covers about 1% of the world's languages. Wikipedia and Common Crawl cover about 4% of the world's languages beyond them. Going further, we can see that the Bible covers about 1,500 languages, so already almost 1/4 of the world's languages. But beyond that, one of the resources that covers probably the largest subset of the world's languages are bilingual lexicons. So simply lists of words and their translations into in a broad set of different languages, which have so far really gone quite unexplored or untapped for NLP research. And here, just kind of to conclude the talk, I just want to highlight like one example which we can use this kind of very multilingual but somewhat quite scarce research by generating additional data on which you can then train our models or fine-tune them on. And to provide a bit more context, at the moment, if you want to adapt a multilingual model that was already trained to a new language or to a broader set of languages, there are two kind of prevalent strategies to do that. The first one that I call here target language adaptation is by doing unlabeled adaptation of the model. So if you have monolingual data in your target language, you can simply continue pre-training your model on this additional monolingual data using your original pre-trained task. And the resulting model will then kind of be more specialized to that language and will, in general, from what we've seen, perform much better in this new language. In addition, if you have also, or as well, an machine translation system that was either already available for a language pair like English and your target language, or if you have parallel data to train the machine translation system, then you can also translate the label data in your target task, typically in English, from the target language from English to your target language, and train your new model on this translated data now. And also this in practice yields kind of a strong performance improvement, and so much so that most state-of-the-art approaches for different evaluation studies essentially use translate train across many different languages in order to achieve the state-of-the-art performance. So now if we can combine these two approaches with word-to-word translation using these bilingual lexicons by essentially generating very simple and very much synthetic data that we can use and leverage in these two strategies. And in both cases, we simply use and go through our existing data, so the monolingual data in English here, and use our bilingual lexicon to simply replace English words if they occur in the lexicon with a translation in the target language. And we basically do both of these scenarios for assuming kind of a setting like no text setting or the few text setting that I mentioned before, where we basically have almost no monolingual data available and no parallel data available for these languages. In addition, we can also do this for the task data, where we also replace words in our English label task data with the corresponding translation in the target language. And as you might expect, because these data sets are very, we do very simple form of translations, there will be likely a lot of issues in the resulting kind of pseudo monolingual or pseudo task data. So we can do additional things in trying to improve the quality by trying to augment and increase the coverage of our lexicon using additional parallel data that we might have available. Or we can try to improve the quality of our fine-tuned model by trying to distill and improve and fix potential label errors using a model that we've initially trained on the target task data in English. And just to kind of briefly share the results here. So in the setting where we assume we do not have any monolingual data at all for training models on different languages, we basically compare here against the multilingual BERT model that I mentioned before across a number of different tasks from the entity recognition to different structural prediction tasks. And we can see here then general translating the task data, so pseudo fine-tuning works best. And in a setting where we also have some amount of monolingual data on which you can additionally fine-tune the model on, we can see that actually augmenting this monolingual data with our pseudo-translated data performs the best here and achieves the biggest improvement over the baseline in most cases. So with that, I'm almost at the end of the talk. I just want to highlight kind of in light of kind of recent advances in NLP and of new emerging research in this area. Just wanted to take a couple of minutes just talking about how multilingual data can factor into kind of more recent paradigms, in particular with regard to use in like prompting with kind of in context learned models like GPT-3 or kind of new models that are trained in this fashion. And here you can basically kind of see the standard like, prompting setup, how it's been popularized by GPT-3, for instance, where we have an input prompt, like a question here. This is for a mathematical reasoning problem, and then an answer. And we basically try to supply the model with in-context exemplars that the model sees before then producing the final answer for a given reasoning problem. In contrast, there's also kind of different ways in which we can augment this standard prompting setup by introducing additional information or additional reasoning steps. And one kind of recently popular way to do this is to use what has been kind of called chain of thought prompting, by additionally providing the model with an instruction or training the model to generate this chain of thought. So basically kind of a summary of different reasoning steps that it can then use to arrive at the corresponding answer here. So in this case, the chain of thought is basically, rather than predicting the answer directly, first predicting the sequence of different reasoning steps, which has been shown to be particularly useful for tasks and applications that require some reasoning component, like common sense reasoning or reasoning with these types of mathematical problems, where there's like one answer, but there might be multiple intermediate steps that a model might need to perform implicitly. So in the multilingual setting, I think there's kind of more questions and more ways in which these like prompting setups can be tackled as well. So here on the left, for instance, you can see kind of a native exemplar prompt where all of the prompt as well as the chain of thought and the answer is produced in the same language, like in Bengali, for instance. And on the right, we have, for instance, combining information and exemplars in different languages like Russian and Chinese, as well as Bengali, and then requiring the model to still produce the output in Bengali here, for instance. And in practice, I think this kind of future learning or instruction tuning paradigm, I think is kind of a major threat and kind of reveals, I think, one of the most exciting like capabilities of these recent models. And I think there's still a lot of interesting work to be done, really figuring out how to make these kind of instructions and prompts most useful in a multilingual setting, looking at how we can maybe automatically get or automatically augment prompts and make them more relevant in multilingual settings, and to simply kind of scale this up or train or enable models to generate actually more fluent content, particularly for more long form generations or for kind of more challenging generative problems in different languages. So with that, the kind of main takeaways from this section are essentially that I think it's really important to generate data that actually reflects needs of local communities. I think with regard to the development of models, focusing on multi-modal data sources and particularly covering looking for alternative data sources that maybe have so far been neglected or not really well represented in research, I think can yield some inspiration. And so with that, I think now is quite an exciting time to work in this area. Overall, I think there's really kind of a lot of momentum and increasing awareness and appreciation that work that goes beyond just supporting a single language or a single handful of languages in NLP is really important and can yield a lot of benefits to people. And so in the spirit of Mazakane, which in Zulu means let us build together, yeah, just want to end with this because I think it's really something that doesn't take an individual group or an individual organization, but it's really needs a community to work on this space together. So yeah, thanks so much for inviting me and for listening to the talk.